functions, and we've done some discovery about what the sine and cosine functions mean. We've also done a little bit of work with definitions of amplitude, period, frequency, phase shift, vertical shift, and now we get into some of the problems that ask us to graph and give this information: amplitude, period, frequencies, vertical shift, phase shift. Okay, so let's start with this first function here. But before we get things going, I just want to remind everybody about the original values here, or the parent functions, that's sine and cosine. Okay? Parent functions, sine and cosine. So for the original parent functions, the amplitude is 1, the period is 2 pi, the frequency is 1 over 2 pi, the phase shift is 0 because you're not moving it anywhere, and the vertical shift is also 0 for the original function, okay? For the original parent functions. And we need to know this information so that we can determine that same information for a different function. And so clearly this function for sine of x is a little bit different than the parent functions, but not too different. So when we think about this in terms of transformations, this number here is a vertical stretch by a factor of 4. Okay? That's all that it's doing. It's not adding anything to the inside here. It's not adding anything to the outside. It's not multiplying anything. So we can answer, so the only thing that this is going to affect is the amplitude, since it's stretching it. Okay, so a quick sketch here. If this is the parent function, okay, so if this is the parent, this is sine of x. For sine of x, in theory, should just do this. It should just do the same thing, but everything's bigger. Okay? And this is a very, very rough sketch. So I'm going to erase this and then just actually graph it for real. Okay? But in theory, that's what it should do. Okay? Because the period doesn't change, so I'm going to actually write these answers down. The period is still 2 pi. That means the frequency doesn't change. It's still 1 over 2 pi. And the phase shift, vertical shift, I'm going to abbreviate this P shift and V shift. This is still 0. And the only thing that's changing here should be the amplitude. And since it's being stretched out by a factor of 4, the new amplitude should be 4. And so I'm going to use my grapher here. I'm going to use GeoGebra. And I've already have sine of x graphed. And let's try and graph 4 sine of x. And let me label this with a slightly different color here so you can see. And you can see that it actually, our intuition and our hypothesis was completely correct, because in fact it didn't really do a whole lot to the graph. All it did was stretch everything out. And so I'm going to switch back to my whiteboard here, and I'm going to graph this again, but much more neatly, much more accurately, and you should do the same as well. So it's the exact same thing as it was before, but instead of going from +1 to -1, it's going to go from +4 to -4, and I'm going to create increments of pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to do the exact same thing over here. -pi over 2, -pi, -3 pi over 2, and -2 pi. And then I can graph my function. And keep in mind, if you look at the original sine function, this will also be very helpful to you. Okay. Just remember where all of the maximum values are occurring and all of the minimum values are occurring. And I'm also going to sketch my unit circle here on the side, because that's often very helpful as well. Okay. So at 0, it's sine, remember, is the y value, so it's 0. It's going to hit its maximum at pi over 2. It's going to hit 0 at pi, it's going to hit its minimum at -4, and it's going to go back here. So on the positive side, this is the graph that I have. Same thing with these points here. And there you go. That's a pretty solid graph. And these right here answer many of the questions, or actually all of the parts that we were looking for. Okay. All right, so that answers that question. Let's continue and let's look at a couple other examples. So I'm gonna post up here. This is example 2. And this time it involves vertical stretch, horizontal stretch, and shrink. So it has -4 sine of 3x. Okay, so I'm just gonna erase this, and I'm gonna leave all this stuff the same. And we're gonna look at our new function, our second example here, which is f of x equals -4, times the sine of 3x. Okay. And as always, when there are transformations, you need to first of all figure out what those transformations are. So this here, 4, so this is a vertical stretch of 4. The negative here reflects vertically over the x-axis. And this 3 right here, it's actually a horizontal shrink to the size of 1/3. Okay? And now these things are going to affect some of our answers. So let's start with the amplitude. The amplitude was originally 1, but it's been stretched out by 4. So it's going to be equal to +4. Now, some of you might be wondering, why isn't it -4? Well, this is really just the distance between the top and the bottom. And this negative flips everything, but it doesn't change the distance. And I'll show you the graph of that in a minute, and hopefully that'll clarify this idea. The horizontal shrink here, it's squeezing the waves together. So if I have this wave right here, this repeats every 2 pi units. If I shrink it down to 1/3, it's going to squeeze, it's going to take these waves and squeeze them together. So that's going to change some things quite a bit. The period is going to be 2 pi, because we always start with the parent function, multiplied by the shrink factor, which is 1/3. And so now the period is going to be 2 pi over 3. Okay? That's our new period. It's not doing anything, it's not adding anything, so there's no shift up and down any way, shape, or form. So we can say for now that the phase shift, okay, and the vertical shift are both equal to 0, because we're not adding anything to the outside or to the inside of the function. Okay. And so let's graph this, and you can see a better picture of what I mean. So we are going to graph for -4 sine 3x. And so that can be a little bit overwhelming, but rest assured, everything will be slightly more clear if we can just look at the picture again. Okay, so if we can look at this picture, let me turn on my spotlight feature here. I want to be able to point out some things to you here, that all it really did was flip it back over. Okay. So before, let me get my setup correctly here. It looks like that's not going to work. Oh, there it is. Oh, there it is. So before the waves started out by going upwards, and now the waves are going to go downwards. Okay, that's what the negative is effectively doing. Now, the waves used to go only up to 1, but now it goes up to 4, and it goes down to -4. And that's what this 4 here is doing. And the waves used to have a period of 2 pi. In other words, if you look at this section right here, between 0 and 2 pi, there's only one cycle of the wave. But now the period is smaller. Everything gets shrunk by 1/3. That's this 3 right here. So now you get 1, 2, you can follow the spotlight here, 2, okay, and then another 3 waves. So another way to look at it is before you had one maximum and one minimum within the 2 pi interval, and now you have 1, 2, 3. So a lot of things going on here, but the way that we can relate and make it all make sense is if we just look back at the original functions, okay? And then break down each one of these transformations bit by bit using some of the principles of transformations that we had before. So now that that's there, let me get rid of this thing, and we're going to try and graph this function now. And so let me start by drawing a good picture of this. So it originally went up to 1, now it's going to go up to 4, and likewise it's going to go down to -4. And if you remember the key spots here for the sine function, that I just showed you the cosine. This is the sine function. Okay. It had a maximum at pi over 2. Well, now it's being shrunk to 1/3, so it's going to have a maximum at pi over 2 times 1/3. In other words, it's going to have a maximum at pi over 6. Okay? So it's going to be pi over 2 times 1/3, and that's how you get pi over 6. It had a 0 here originally at pi, so now it's going to have a 0 at pi over 3. So that's just 1/3 of everything that it used to be. It had a minimum at 3 pi over 2. It used to have a minimum at 3 pi over 2. Now it's going to have a minimum of pi over 2. And then it had a 0 again at 2 pi. So now it's going to have a 0 at 2 pi over 3. And we can use this picture there to graph it. And if you notice, it's just the same thing as the wave we had before, but everything is crunched down, so all of these values have changed a little bit. And I can also do the same thing on the other side, negative pi over 6, negative pi over 3, and then negative pi over 2, and then it's going to come down here. Okay? Now, if you look at this picture that I just graphed, and you compare it to the picture we have here in GeoGebra, you can see that it's actually incorrect. What I graphed so far really is not the correct graph, because I did not take into account the negative here. So this would be correct except for the negative. So if it was, we need to factor in this negative here. We need to flip everything. So whatever was maximum now has to become the minimum. So let's look at this picture again. Instead of a max at pi over 6, it actually starts out with a minimum value right here at pi over 6. So I need to just take this picture and just flip everything. And I know this can be frustrating sometimes to draw this, but if you're just careful, you should be able to get this done correctly. So all the maximums are minimums and all the minimums are maximum. Okay, so I want to label here that this is the actual correct graph, -4 sine 3x. It's actually the red lines there, not the purple or the blue lines that I just graphed before. Okay, so that's the actually correct graph. But we had to draw another graph in order to really get a good picture. And as you do more and more of these, you should be able to to use your graphing calculator or use GeoGebra or some other grapher to help you graph this. And I just want to show you how you can graph this on your calculator as well, since you don't necessarily have access to GeoGebra. And one of the first things that you're going to need to do is just make sure that you go to the mode button and make sure that we are in radian mode right here. We do not want to be in degree mode. Okay? So let me show you this. Let me clear everything out. So make sure you are in radian mode. Hit the y equals button. And we can type in, let's type in the sine function, sine of x. And we need to make sure we adjust our scale too. And our scale here needs to be something that is in terms of trigonometry. So instead of between negative 30 and 30, I'm going to go from negative 2 pi as my x min, my x max. Whoops. I actually want this to be a positive 2 pi. The scale, I'm going to go half pi at a time. And the graph will automatically, whoops, what did I do there? Looks like I made a mistake. Let's clear out of that. Okay, let's go back to my window here. Sorry about that. Let's go back to my x scale. It's going to be 0.5, and I want to go and use the pi. So half pi, okay, as my scale. X min, I'm going to go down as far as negative 4. X max, y max, I'm going to go up as high as 4, and we'll increment this by 1, and we'll hit graph. So that's the graph of y equals sine of x. I can also graph the other function in there as well, and if you have color, it's especially nice. So we're gonna graph negative 4 sine of 3x. And if we have everything in our window expressed in terms of pi, you can see that these tick marks here line up really nicely to what we're looking for. So you can see the graph starting to sketch itself right there. Okay. And there you have it, a way to graph this using just plain regular graphing by hand, using your TI-8384 graphing calculator. You can also use GeoGebra if you have it, but you should get used to doing this with your graphing calculator, because you need those for quizzes and tests. And most importantly, we need to be able to understand where these numbers really come from. These numbers like, what's the amplitude going to be? What's the period going to be? And we haven't done examples with different phase shift and vertical shift yet, okay? But that will be something that we pick up in the next video. Thank you for watching, and have a wonderful day or evening. And until next time.